Hello, we're glad you joined us today to learn the insulation techniques used to retrofit existing homes. CertainTeed is committed to helping people reduce their impact on the environment, and we believe upgrading insulation is an excellent way to achieve this goal. You know, according to the Department of Energy, to get the biggest savings, the best and easiest place to add insulation is usually in the attic. First, we're going to talk about loose fill. But before we get into the nuts and bolts of installing insulation in attics, we want to emphasize the importance of the energy audit as the first step in the weatherization process. You've got to find out where cool air or heat is escaping and seal these openings, or you won't get the maximum benefit of insulation. If a professional energy audit has been performed on the house before you're called in to insulate, the areas that need to be sealed will have been identified. If no audit has been completed, you'll need to find the leaks yourself. Here's where to look. Leaks are often found in the following areas: joints, seams, and penetrations, openings between window and door assemblies and their respective jambs and framing, utility penetrations, walls and ceilings separating a garage from conditioned spaces, attic access openings, site-built windows, doors, and skylights, sills and baseboards, drop ceilings or chases adjacent to exterior walls, knee walls, behind tubs and showers on exterior walls, and common walls between dwelling units. Sealing leaks and openings in the attic is particularly important. That's because the attic is usually the easiest place to add insulation, and, according to the Department of Energy, the area where more insulation will generate the biggest savings. Unsealed openings allow excess air to penetrate the attic, reducing the effectiveness of the insulation. Installing attic insulation without first taking care of the leaks is very inefficient. Look for attic air leaks in 7 prime areas: between floor joists, joints where drywall meets the top plate and the nailer, open soffit, electrical and plumbing penetrations, lighting and fan penetrations, attic hatch, and furnace flue. These penetrations may be covered by existing insulation, or they may be uncovered. Either way, careful inspection of the entire attic is recommended. Your goal is to seal every unauthorized opening in the attic, both those that allow outside air to enter and those that lead to downstairs living areas. The only authorized openings are the attic vents, which we'll discuss in a minute. Seal these openings with caulk or foam. Fill every gap. For example, look carefully behind and underneath electrical boxes to make sure you've sealed all the way around. When addressing air leaks in the attic, you must be careful to ensure proper ventilation. Sealing leaks while leaving soffit and roof ridge vents uncovered may seem contradictory, but both steps are vitally important for managing the hot air, cold air, and moisture that can affect comfort, energy usage, and structural components of the home. You may need to install baffles to keep the insulation from covering the soffit vents. Position the baffles between each joist and make sure they're high enough to extend above the level of insulation to be installed. So now that you've sealed all unwanted air leaks and made sure the attic is properly ventilated, you're almost ready to insulate. But first, you have to determine how much insulation is needed. A quick way is to look across the uncovered attic floor. If the insulation is level with or below the attic floor joists, more insulation should be added. A more scientific method is an energy audit, which can quickly show if an attic is under-insulated. Infrared imaging will identify the attic's thermal performance by taking a picture of hot and cold spots. Areas with insufficient insulation will be apparent. The recommended insulation level for most attics is R38, or about 12 to 15 inches depending on the insulation type. In the coldest climates, insulating up to R49 is recommended. This map, available on the Department of Energy website, shows recommended attic R values for different areas of the country. Once you've determined that the attic doesn't have enough insulation, you have to figure out how much to add to achieve the desired R value. Now, the energy auditor may have calculated the necessary amount, but it's still your responsibility as the contractor to confirm this estimate in order to ensure a proper and effective installation. Two types of fiberglass insulation can be retrofit into attic spaces: loose fill and batts and rolls. First, we're going to talk about loose fill. There's a chart on bags of loose fill insulation that will help you figure out how much you need. For example, if you want an R value of 30, you need about 15 bags for every 1,000 square feet. Now look at the R30 requirements. The contents of the bag should cover no more than 67 square feet, and the installed insulation should be at least 11 3/4 inches thick. Here's a trick many professional installers use to figure out how to blow insulation evenly into the whole attic area. Mentally divide the attic into sections. For example, let's say you've determined that you need a total of 12 bags for the attic. Divide the area into quarters and plan to use 3 bags for each section. Fiberglass loose fill insulation is installed using a pneumatic machine that literally blows the high performance insulation through a hose assembly and into the attic. The machine must be able to properly condition the material and provide uniform material flow and the correct air volume. The machine will need the following features: an adequate shredding system to break apart and condition the compressed insulation, a gasketed vaned rotary airlock feeder section, a blower capable of providing at least 2 pounds per square inch of air pressure, a slide gate to control material feed into and out of the shredding area, and an internally corrugated plastic blowing hose. There are some general guidelines that apply to all machines. Slide gates are typically left halfway to fully open for attic installations. Opening the gate increases material flow. Machines with transmissions or gearboxes usually have 4 gears. 3rd or 4th gear is best for attic installations. Minimum hose length should be 150 feet, with an inside diameter of between 2 and 3 inches. Machine air pressure should be adjusted by changing either the motor RPMs or the air relief valve setting. Air pressure helps determine the material arc length, which, as you will see, is an important factor in achieving proper insulation thickness. More detailed step-by-step instructions are available from CertainTeed. Contact your CertainTeed representative or visit certainteed.com/insulation for downloadable installation resources. Safety is a key concern when you're using an insulation blowing machine. Here are some important things to remember. Always wear a disposable dust respirator and eye and ear protection when loading the machine, even when standing nearby. It's also a good idea to wear a long-sleeve shirt, gloves, and sturdy shoes. Wear a hard hat if roofing nails are protruding through the attic ceiling. Step on the joists, as attic ceilings will not support your weight. Never overfill the hopper. Never put your hands or any other objects into the hopper while the machine is turned on. If you drop something into the hopper, use the emergency shutoff switch to quickly stop the machine before any damage occurs. Make sure the machine is completely off before trying to retrieve the object. Never try to adjust the machine while it's running. Turn it off first. Make sure the machine's exhaust is vented away from the blower air intake area. If you have the machine in your truck, vent the exhaust to the outside. Before you start blowing insulation, you should vacuum out any cellulose that may be present in the attic. Though fiberglass loose fill can be blown over existing cellulose, it's not recommended. And batts and rolls should never be installed on top of cellulose. Their weight will compress the cellulose, thus reducing its R value. Now install flashing or a top hat around any recessed lighting that is not IC rated. Leave at least 3 inches between the flashing and light to prevent these fixtures from overheating. For other vents, kitchen or bathroom fans for example, refer to the manufacturer's manuals and installation instructions for details. Attic rulers are necessary to help you fill the attic with a uniform thickness of insulation. Staple the cardboard rulers evenly throughout the attic, with one for about every 250 square feet. You'll want to blow the insulation until it's level with the desired R value marked on the ruler. Installing loose fill insulation is a two-person job, and it's important to have a good communication system between the operator in the attic and the person loading insulation into the machine. When pulling the hose into the attic, use drop cloths or plastic sheeting to protect the home as you carry the hose upstairs. When you start, work from the eaves toward the middle, starting at the far side of the attic from the hatch. Hold the hose parallel to the floor. Make sure the arc of material is 10 to 12 feet in length and that you move it back and forth in a smooth, level fashion, blowing the insulation in the same direction as, not across the joists. Cover all areas of the attic, but don't fill any vents or recessed light areas. Don't let the insulation bounce off the floor, roof, or trusses, as this can cause compression that will reduce coverage and R value. Whenever possible, avoid cupping your hand to direct the insulation. Too much cupping compresses the insulation. In smaller spaces, cut down on the machine's air pressure or RPMs to shorten the throw and gain more control. It's okay to cup with your hand to direct the flow into these tighter areas. You can use the blowing machine to even out the insulation and ensure uniform coverage. Simply close off the material feed and direct the airflow from the hose to even out the material. The final step is to attach a piece of batt insulation on top of the access hatch and carefully lower the hatch back into place as you exit the attic. Installing fiberglass batts and rolls in the attic is pretty easy, but there are a few things you need to know. First, you'll probably have to cut your insulation to fit different spaces. Here's how to do it. Lay the insulation on a board with a ruler or other straight edge over the area to be cut. Press the straight edge down hard and cut with a utility knife, using the straight edge as a guide. Use a sharp blade for best results. Lay unfaced insulation directly on top of the existing insulation between the floor joists. Use rolls for ease of installation in larger spans. Now that you've filled in the areas between the joists, you're ready to add more insulation to reach the desired R value. Starting at one side of the attic and working towards the hatch, place unfaced insulation perpendicular to the joists. Make sure the batts butt up tightly against each other, both at the ends and along the sides. There should not be any voids between the batts. If necessary, push insulation under the eaves, but don't cover attic vents with insulation. If you encounter pipes, beams, or other obstructions, cut the insulation carefully to fit snugly around them. Do not cover lighting fixtures or exhaust fan motors protruding into the attic. As with loose fill, leave a 3-inch space between the insulation and electric motors or lighting fixtures unless the lighting fixtures are IC rated. Fiberglass loose fill insulation is the perfect product for retrofitting exterior walls, which are walls whose outer surface faces the outside. This is because all you have to do is drill holes to gain access to the stud cavities. We'll talk now about some things you need to know. And remember, you can find out more from the CertainTeed Optima installation guide, which is available from your CertainTeed representative or at certainteed.com/insulation. First, check the structural soundness of the drywall or plaster wall facings. If they're weak or poorly attached, the pressure created by the blowing process could cause damage. Also check for signs of moisture damage such as blistering paint, mildew, and stains. Next, you'll need to reference the energy audit to identify the spaces behind the walls where insulation was found to be lacking. Infrared images are an excellent guide for finding these spots. If no audit was completed, determine the distance between studs to measure the volume of the wall cavities. The homeowners may be able to tell you whether there is any insulation in there. If not, the holes you drill to install the loose fill insulation will provide access and enable you to evaluate existing insulation levels. We'll discuss the holes in a little while. Check for fire stops. Tap on the walls from inside the home. If present, fire stops will usually be mid-height. Holes will have to be drilled above and below them to fully insulate the wall. Note and mark all areas of the wall that should not be drilled, including wall ducts, vents, recessed cabinets, and service panels. You also need to make sure all existing wall openings are sealed. You don't want the insulation you're blowing into the wall cavity to exit somewhere else. Use gaskets to seal outlet openings, and pull the carpet and molding to caulk base plates. Band joists should also be caulked. Insulation can be blown into the walls from the inside or outside of the house. Exterior installation is suggested if the house is sheathed in siding or wood. Exteriors made of brick or stucco can be drilled from outside, but it's more complicated. You should discuss options with the homeowner and recommend installing Optima from the inside. To create openings through which to blow the insulation, drill at least 2 holes in each vertical wall cavity you plan to fill. One about 3 feet up from the base of the area, the other about 2 feet from the top. Drill holes into cavities above and below windows and fire stops when necessary. The holes should be 2.5 inches in diameter. CertainTeed recommends that blowing machine air pressure be reduced substantially for a wall installation compared to the pressure you would use to blow insulation into an open attic. This will ensure that no damage to the wall occurs. The blowing machine should have an air relief valve for lowering the pressure. A properly filled wall cavity will have a nominal density of 1.6 pounds per cubic foot. Insert the nozzle into the hole and blow downward, then blow upward. However, don't blow more than 3 feet down or 2 feet up from the hole. If the cavity is not completely filled at that point, move on to the next hole and repeat the procedure. After the walls have been filled, you'll have to clean up and plug the holes you drilled. For interior holes, use tapered 3/4 inch wood or styrofoam plugs. Spackle and tape the drywall after inserting the plugs. For outside holes, plastic or wood plugs of the same dimensions are best. Caulk around the plugs and restore the siding or other exterior cladding. As you know, crawl spaces are open spaces underneath a portion of the home, and an uninsulated crawl space can make the floors above it cold in the winter and hot in the summer, affecting the comfort of the occupants and forcing heating and cooling systems to work harder than they have to. That's why we're going to show you how to insulate this area. There are 2 common types of crawl spaces, vented and unvented. Vented crawl spaces have openings to the outside, while unvented ones are usually contained within the basement. Some crawl spaces have pipes or ductwork running along the ceiling. Others do not. If ducts or pipes are present, they should be wrapped or insulated in some way. We're going to show how to insulate the walls of an unvented crawl space located in the northeastern United States. But remember, building codes in your area may have different requirements for crawl spaces, so be sure to check them before you begin. Crawl space walls are unfinished, so you need to use basement wall insulation, which comes in blankets rather than the standard batts and rolls. Basement wall insulation has a perforated fire-rated facing. The most commonly recommended R values are R11 or R19. The first step in any crawlspace project actually involves the floor, not the walls. The floor should be covered with a 4 to 6 mil polyethylene vapor retarder before you turn your attention to insulating the walls. After you've cut the basement wall insulation to fit the space, staple the top edge of the blanket to the base plate or sill above the wall. It's okay if it hangs loosely, you don't need to fasten the bottom edge. As you can see, insulating crawl space walls is pretty easy, but don't forget to check local building codes for any specific requirements in your area. Before we begin this section, a brief word on working overhead and ladder safety. Make sure your ladder is the appropriate height for the area you're working in and that it's sturdy enough to handle the weight. And always use correct technique for placement and climbing. These instructions apply to any ceiling in an unheated area, whether it's a basement, crawl space, or below-grade garage. First, you must seal and insulate band joists which rest on top of the foundation. Caulk or foam the joint where the wood meets the foundation, then place a strip of fiberglass insulation along the area all around the basement. Now you're ready to install Batt insulation between the joists. If you're using faced insulation, place the face side toward the interior of the house. The easiest way to hold batts or rolls in place is with rigid wire fasteners with pointed ends. Make sure they're wider than the joist spacing and simply wedge them into the space between the joists. You can also staple mesh screen or chicken wire to the bottom of the joists, or lace wire back and forth around nails hammered into the bottom of the joists. It's important to note before we get started that only conditioned basements and garage spaces should be insulated. Knee walls are often found on the second floor of Cape Cod-style homes and should also be insulated. If the walls have finished drywall but no insulation, follow the procedures outlined earlier for adding loose fill insulation to wall cavities, and be sure to insulate behind plumbing. If the walls are unfinished, you'll have to add studs before you can insulate. Place them 16 or 24 inches apart, measuring from the center of one stud to the center of the next one. Check local codes to find out whether a vapor retarder is required. Place R13 or R15 insulation between the studs. When you're finished, don't leave the insulation exposed. Cover it with drywall or some other type of wallboard. We hope this video has helped to clarify the important role insulation plays in the weatherization process. CertainTeed offers many resources for weatherization professionals. Check out our website or contact us for more information.